to all the attendees who have joined now. So happy to welcome you all. We'll be starting very shortly. Okay, I think we're set to go. Okay, so a warm welcome to all of you, to each and every one of you who are attending this session. So we are so excited for this session. So I'm Karthik, the chapter lead of NeuroTech X India. So we're so happy and excited to have such wonderful speakers and wonderful attendees. So on one starting note, we would like to welcome you all to the future. So we are going to take you and we are going to travel together, sort of time travel and look at what are the future technologies and so. So as you would have seen the movie Terminal, so where Victor Nowosky was ordered by Dixon saying the American soil is open for 5 minutes. So we at NTX say the future is open for 2 days. So we assure you, we are going to give you a great experience for both the speakers and the attendees. I think we have got diverse attendees ranging from enthusiasts, professionals all over the world. We've got a great set of speakers and attendees. So it's going to be a great event. I hope all of you enjoy the event. So, okay. So this is, as you all know, Neuro 2.0, futuristic trends in neurotechnology. So the main objective behind coming up with the idea of this event is we have 3 main objectives. So one major objective that we thought of is to provide an out-of-the-world experience for all the attendees and speakers. We care more for the experience, even though there's a lot of other things in this knowledge or discussions network. There are a lot of other things which you can enjoy in this webinar, but we care more on your experience. We assure you, you're going to have a great experience in this webinar. And we're also going to show you a peek into the future where you're going to have an amazing set of speakers talking about future technologies. So on a final note, with this webinar, the major objective that we had is, as you all know, the field of neurotechnology is growing very faster. That in, say 5 or 10 years from now, we are going to see neurotechnology in each and every field present out there. So there's one single platform we are organizing on behalf of NeuroTech X India. So this is one single platform where we can join hands together and build the future together and serve humanity. So as you all know, we have got a wonderful set of speaker lineup. So for day one, we have got Dr. Shikhar Chaudhary from NeuroTechnology, Dr. Naveen Gupta from IIT Guwahati, and Dr. Max Newland from Brindco, USA. And you're sure we have got in day two, we've got Dr. David Eagleman, who's the co-founder and CEO of Neosensory and also an adjunct professor at Stanford. We've got Dr. Priya Tikka, a research professor in Thailand University, and also Dr. Isabella. So if you see the topics are very diverse, touching upon different futuristic aspects of neurotechnology. So you're going to have a great dopamine rush during the whole event. So when this is the day one agenda, we're going to have first Dr. Naveen Gupta talking about neurohealth, and we're going to go to Dr. Max talking about neuroeducation, and again to Dr. Shikhar talking about neuromarketing. And we're going to have an interesting panel discussion and a Q&A sessions, which I would strongly suggest all of you to participate. And for day two, we're going to have the neurocinematics talk by Dr. Priya Tikka, and the neuroarchitecture talk by Dr. Isabella, and neurocognition talk by Dr. Eagleman. And we're also going to have the panel discussion in day two. So one strong recommendation for all the attendees here is in the end of day two panel discussion, we are going to have a signature event of Neurotech X called Neuro Bar, where you'll be split into different lobbies. You can join any lobbies, and the speakers will be split into different lobbies. You can interact with the speakers, interact with other members of Neurotech X, and also the other attendees present. That's going to be really a huge opportunity for all of you to network and also let others know what you're doing in the field and what you want to do in the field. So the main objective, as I already mentioned, the main objective of this webinar is to experience the webinar, not just gaining knowledge. So I'd strongly suggest all the speakers and the attendees to participate in the Neuro Bar. It's going to be an amazing experience. So we have a really passionate team in Neurotech X India. So basically to introduce Neurotech X India, so we started 2 months back. It's a very fresh initiative, Neurotech X India. We work on one single mission to advance the progress of neurotechnology in India. So as you all know, there are a lot of things that are rapidly growing in India. So we take this responsibility by acting as a catalyst to advance the progress of neurotechnology and achieving this mission by working hard and utilizing all the talent pool that we here in India. So our major objective is to make India and also a leader in neurotechnology and also advancing the progress of neurotechnology. So regarding our team, so I'm the chapter lead, and we have Suhaila Kapoor, our advisor. I'd like to I'd request all my team members to just switch on the video so that attendees can see. I'd like to introduce Suhaila Kapoor, our advisor, and I'd like to introduce Santana Gopalan, our projects lead, Kalidas, our content lead, Dhanushya Shri, our marketing and communications lead, and Suraj Patil, who has been working on promotions. And also our main sort of godfather for us is Brian Jenkins, godfather for all the chapters. So he's here, and also our most favorable Yannick Roy, the co-founder of Neurotech X. And we also have Mohit Patil, who has been very supportive for putting up this webinar. So there are certain important things that I would like to share with you. What you can expect from this webinar is one thing that I would like all the attendees to know even before getting into the webinar. So one gift that we have for you is we have got an extraordinary speaker lineup for you who's going to touch upon different topics. And these speakers are most world-renowned speakers who's going to really give an attractive and interesting presentation that's going to intellectually trigger you to put up a lot of questions. And I would obviously appreciate you to put up a lot of questions, but it's going to be a very curious session. So, and what we also have a gift or a surprise speakers who are going to present in this webinar. What we are going to have we are already having an amazing audience. So if you see the people who have registered for this session, we are going to have a diverse range of people, and even in terms of region, in terms of talent pool and diversity, we have got researchers, professors, we've got professionals, and also starters, enthusiast students. So that's going to be a great gift for the speakers too. Our major goal is also to make them comfortable and provide a comfortable experience. So we, as I already said, we care for the wholesome experience, not just for the knowledge or other aspects of the webinar. And Q&As, I would strongly suggest you to take part in the Q&As, ask as many questions as possible. So even if the speakers are not able to answer it, we'll make sure to get your questions, get the speakers, talk to the speakers, and get back to you with their answers. So, and as I've already mentioned, the diversity of attendees is huge, and you're going to have a great networking session. Next, I would strongly suggest all of you to participate in NeuroBar, which is a great place to network. And the social media contest that's going to be done while the event goes. Please check out the social media handles of NeuroTech X, mainly in Twitter, LinkedIn, to get updated about that. So yeah, this is my final note. Let's build the future together and serve humanity together. Let's time travel to the future. So now we can go for the sessions, no more waiting. We can go to our first speaker, Dr. Naveen Gupta. So Dr. Naveen Gupta is currently an assistant professor with the Department of Biosciences, Bioengineering at IIT Guwahati, working in areas of brain-computer interfaces, imaging genetics for psychiatric disorders, multimodal and multivariate algorithm development, and designing wearable medical solutions for patient mobility. He completed his postdoctoral training in the area of schizophrenia, imaging genetics on a joint National Institute of Health grant between Mind Research Network and Georgia State University, USA, publishing in numerous high-impact journals. Previously, he obtained his PhD from Brain-Computer Interfaces and Neural Engineering Group, University of Essex, fully funded by the Competitive Overseas Research Student Award for International Students and the University of Essex scholarships. His PhD work majorly involved designing an offline P300 BCI system. During his doctoral work, he also explored integrating electroencephalogram and near-infrared spectroscopy modalities for cognitive applications. So Dr. Naveen Gupta is going to speak, have his session on neuro health. And we don't have words to say. We are so much excited for Dr. Naveen Gupta's session. And over to you, Dr. Naveen Gupta.
Thanks, Karthik, for the wonderful introduction. So hi, everyone. So let me share the screen. Hi, yeah, please let me know if you can see the screen.
Yes, Dr. Naveen Gupta, yes, we are able to see.
Okay, yeah. Okay, so I would first like to thank NeuroTech for organizing this wonderful webinar. So I'm really excited to learn a lot of things. I've kept much of the presentation basic. So if by chance, you have questions, you're welcome to ask me. So I'm actually currently, as introduced, I'm with IIT Guwahati, and I'm establishing the Neural Engineering Lab at IIT Guwahati. So let's get into the presentation. So currently, I'm just going to give you a bird's eye view. We are currently looking at real-time BCIs. I'm going to take you from the purist point of view. So let's say if you're, probably play, you know cricket. So it's going to be like a test cricket. So I'm going to start off with test cricket, and then I'm going to take all the way to like T20. So which is like just happening now, right? So it's going to start from the purist all the way to the modern day BCI. So I'm taking it from the basics, and also I'm going to touch upon some multivariate subgrouping algorithm developments which we are doing. I'll not go too much into the math and stuff, but I'll just make it, pretty much clear what exactly we are doing from a bird's eye point of view. Okay, so as you can see on the screen, so this is actually the way BCI started. So everything was inside the lab, but currently you can see everything is sort of going to the daily environs, and people are taking out. As Max and Dr. Shikhar will be, going in detail. So everything is going like, out there for the daily environs. Okay, so that's sort of the electroencephalogram and these brain-computer interfaces. And also the other one which I would be looking into is making sense out of neuroimaging, especially MRI data. So the whole aim is to connect the neuroimaging to the genetics, but I'm just going to focus on the neuroimaging, structural imaging, where we are looking into data mining within disease. So most of the research currently is finding differences between healthy and, let's say, schizophrenia, or healthy and Alzheimer's, healthy and preterm born. But we are planning to look only within the preterm born adults. So this is a project with King's College London, and one interesting aspect is not much algorithms are there out there to find or data mine within the disease. So it'll be great if I can get some exciting views or thoughts on this aspect as well. Okay, so going forward, real-time brain-computer interfaces. As I said, I'm just going to go from the basics, the purest way. So what is BCI? BCI is to give severely paralyzed people. So this was the initial motivation for the development of BCI. So let's say a patient is locked in or affected by stroke. It helps give a communication channel without depending on the muscle control. So that's the main goal of BCI. So what, of course, apart from communication, the brain activity can be used to control external devices. So putting together BCI combines hardware for acquiring the brain signals. it has a cognitive paradigm and also machine learning algorithms. Okay, so pictorially, this is sort of the traditional BCI framework. So you have a paradigm, which is a task is important, and then this is how the data is acquired. So the data can be, this is an electroencephalogram, so it's a non-invasive. I think Max and Dr. Shikhar also will be speaking about it, but there are numerous other ways like fMRI, MEG, and host of modalities to acquire brain data. So, and these are your machine learning classifying steps, which actually extract the features and make sense out as to what the subject or the participant is focusing on during the experiment. Okay. So this is sort of, I mean, neural engineering lab at IIT Guwahati is pretty new. So we are like 3 years old. So some of the research we took quite a long time to establish, get equipment and stuff. So this is one of the quick projects which we did where we developed a P300 speller. So I'll just play the video for you. So you can see that the subject is able to spell a letter. So there's going to be flashes. I mean, the first one, R, is going to be the letter which is required to be spelled. And there's going to be flashes. And he's required to count the number of flashes of R during the task. And the system actually will recognize R with a green, yeah? So he's counting the rows and the columns where the letter R is being flashed. So we took around, it was a quick try with the OpenVibe, and we used some scripts with OpenVibe, and also we did some custom coding. So we were able to, five subjects were able to spell the letter in like under 1 minute in real time. So the computer has predicted R, okay? So this is sort of the P3, I mean, it's based on the P300 speller paradigm. So, I mean, P300, let me explain to you in a simple way, okay? So you're waiting at an airport for your mom or let's say your son, okay? And you're waiting at, let's say, after the immigration, when you're scanning for the people who are coming from the airport. So once you see your mom or your son or let's say your sister, you're excited, right? You don't get that excitement when you see others. But when you're focusing on someone, you're going, and you're trying to look out for them, you're going to get that P300 potential, which is the evoke potential. So that's the basic idea. I put it in a very vanilla flavor for you. So that he's focusing on the letter R. It's like how I explained that when you're waiting at an airport for your mother or your son, okay? So that is sort of the spelling device which we have developed. That's the purest way of brain-computer interfaces. But currently, anything can be called as brain-computer interface. So it need not be just the brain signals, but it can be even eye blinks, muscle movement. So as long as you're able to map your biosignals into state predictions, so that is currently being called as BCI. So that, I mean, as long as the system works, so right? It's fine. We use muscle or eye blinks, right? So this is the modern BCI definition. So one other project which we are currently looking at is electroencephalogram on the move. So as I said, much of the research is moving outside the lab and people are interested in, let's say, knowing the stress levels in a daily environment, or let's say if some epileptic patient has been discharged from a hospital, you want to collect epileptic data, the EEG data from him. So electroencephalogram on the move collection is sort of, pretty much exciting and in the need of the hour. So on that aspect, what we are looking at is we're designing a system wherein a person can move around freely, and he's also we use the concealed ear EEG so that we don't have the tap, and it sort of streams, the data streams to your smartphone, right? We have a few exciting parts of this project. Still it's ongoing and we have not published. So I will refrain from revealing quite a lot of facts. So just to show that how compatible it is and easy for him to move around. So you can see that the data is getting recorded as well, and he's able to go about doing his daily tasks. So there's no need of a headband, and it can be the ear EG can pretty much be concealed. Yeah. So the main thing, with the, let's say, if using it as an epileptic Holter device. So you want to know the events, the exact time, let's say when that event happened. So we are looking into, getting the event information also with the EEG and with the camera data. So that is something exciting, which we hope to publish in the next few months. So that is one other project. So I would be happy to take your questions or suggestions to take this forward, forward, or make it more exciting. So that is one aspect of the presentation. So as I said, I'm going to also discuss about multivariate and multimodal subgrouping algorithms. So this is the part which I'm going to sort of discuss next. Okay, so let me give you an introduction to preterm born adults. So why study preterm born adults? So preterm born adults percentage is, the worldwide occurrence of preterm born adults is around 5 to 13%, who are like born within 35 months of gestation, and very preterm born are like if they are born within 30 months of gestation, which is around like 1.5%. And more preterm born babies are surviving. That is, they are surviving and they are sort of going into their adulthood at the moment. So in such cases, incidence of cerebral palsy is around 5 to 10%. And most of the preterm born adults seem to have cognitive or behavioral problems after they are grown. So, so currently with King's College London, we are looking at differences in their brain development in a longitudinal data set. And as I said, what we are looking at is we are looking for differences within the group. So we're not considering healthy controls. We are just considering preterm born adults. So that's the basic goal of this project. So let me just take you for more, give you more details about preterm born adults. So about 25% of preterm born adults have a psychiatric disorder. So they end up having like autism spectrum disorder, emotional disorders, or attention deficit and hyperactivity disorders as well. So it makes sense that we look at their data, right? So that's where this project is heading to. So how do we analyze data from, though we are looking at only preterm born adults, let me just take you back, take the story back from as to how the data was analyzed and how currently everyone, the research group, the research fraternity is analyzing the data. So how do we analyze data from preterm born adults and healthy controls, structural MRI data? So let's say we have group 1 as healthy control and group 2 as preterm born adults. So let's say we have so many subjects, so n subjects MRI. So this is sort of a voxel based comparison. So the gray matter density is compared, and then it's sort of statistical analysis is done to know whether the voxel, the gray matter density at this voxel for group 1 is high, or whether the gray matter density for group 2 at this voxel across the population. So the comparison is across the population. Okay. So this gives you differences in the region. So let's say if this is your brain, right, which is represented by the MRI. And if you do a univariate analysis, you're going to get the regions which are differing between the two groups. And if you do a multivariate analysis, you're going to get the regions. Also, you're going to get the relationship between these regions. Okay. So I hope I made it clear to you. So preterm born adults, the research so far, as I said, most of the research has been looking at preterm and controls. So you can see that the preterm, the areas, the voxels around this regions of the brain, the insular and the insular part of the brain seems to have lesser gray matter than the controls. Okay, so this is at the age of 15. So again, this research was done considering controls as well. So if you look at 19, the differences have increased. So the gray matter density of preterm born adults are less in a lot of regions. If you look from the previous slide, in this slide, the regions, are little, whereas it's more conspicuous and has increased in these regions. Okay. So you see that the gray matter loss seems to be sort of, increasing over time, over the age of the subjects. So that's what we are actually, we have a data set which is longitudinal. So we have a data set at 15, 19, and 30. And we are looking as to how the variation of the regions which are differing in gray matter varying across time. So that is one aspect. One other aspect, as I said, is within the group. So research so far, as I told you, has been involved with healthy controls and sort of preterm born adults. So, but we are currently looking at how can we look within the groups and to find out subgroups. So data-driven subgrouping is something which we are trying to find subgroups within the preterm cohorts. So the approach we are using is we are taking the MRI data, we are subgrouping it, and then we are sort of looking for clinical symptom association. So let me just explain one sort of technique wherein we are using biclustering. So let's say if each of the each of the MRI can be concatenated into a row. Okay. So as I showed you the N MRIs, from the preterms, the first row would be the MRI data from the first subject, and so let's say the 10th row would be the MRI from gray matter volume from the 10th subject. And let's say the last row, if 100th subject, it's going to be the MRI data from the 100th subject. Okay. So we do a multivariate analysis and we sort of get the regions which are co-varying together. So we do a PCA and ICA. I'll not get into the mathematics of it. So we get the covariation of these, let's say 100 subjects. So this axis is your subject axis. So we get the covariation of gray matter in these regions in this vector. Okay. And the covariation of the voxels regions over here is captured in this vector. Okay. So this subject by voxel matrix is nothing but data from 100 MRIs of preterm born babies or preterm born adults. Okay. So now what we do is we sort of sort the loadings, and by sorting the loadings, we are trying to group the subjects which are similar. So these are the covariations, right? So we are grouping it. You see the shading. So these are highly weighted and these are not much highly weighted on this component. So similarly, we have given a shading over here. These subjects at the top, the 100 subjects, right? This is going to be a 1/100 vector, right? So the subjects at the top are highly weighted in gray matter than the subjects at the bottom. So what you do is you sort of do a intersect. You intersect and then you can come across to 3 subgroups. One set of subjects which are highly weighted on component A1, which is corresponding to this region of the brain. So, and a group sub S2, which is weighted on this component. And you have another subgroup called S inter, which is sort of weighted highly on both the components. So in this way, we are trying to sort of partition the subject by voxel matrix into similarly small, into similar sized submatrices, similar submatrices. So this is one submatrix, and this is another submatrix, and this is another submatrix. Okay. So the whole idea is to subgroup the MRI data for preterm born cohorts. Okay. So that's the whole idea which is being implemented over here. So technically, we have actually subgrouped the subject axis, so the subject dimension. So the voxel dimension also can be similarly subgrouped, and the regions will also differ. So each subgroup will have its own map, and the regions would be differing between the subgroups. So this could lead to additional regions being sort of deciphered, and more accurate quantification of the regions which are differing within the subgroups can be achieved using this technique. So this is one other work which we are currently doing. So it will be exciting to take some questions. Before that, I would like to acknowledge some of our grant agencies. So these are some grant agencies which are funding our work at IIT Guwahati. And last but not least, I'd like to thank my lab members who have been supporting, and also it's been a great learning experience. So I'd like to thank NeuroTech once again for giving me this wonderful opportunity. So I pass on the session to Karthik again. Thanks.
I think so. Thank you so much, Dr. Naveen Gupta. So one small thing is we'll have please post your questions in the Q&A so that after the three speaker sessions, we are going to have an interesting panel discussion where we'll be having getting your questions to the speakers. Thank you. I'll hand over to Santana Gopalan. Yeah.
Okay, guys. I don't know about you. I just got chills. I love the whole talk, especially the bits about the real-time spiller and the alpha technology. I personally feel that you would have inspired a lot of people here today. Thank you for an insightful and an exciting talk, Doctor. Next up, we have Dr. Max Newland. Max Newland is the president of BrainCo USA. But before talking about BrainCo, I would like to talk more about Max Newland. After graduating from the University of Connecticut with a degree in cognitive science, Max spent several years of working simultaneously at National Institute of Clinical Application of Behavioral Medicine, Massachusetts General Hospital, and Beth Israel Deaconess Medical Center in various fMRI research labs, investigating the impact of meditation on the brain, as well as invasive deep brain stimulation on Parkinson's disease. In 2016, he graduated with a master's degree in human development and psychology from Harvard University before joining BrainCo. Okay, now about BrainCo. BrainCo is a brain-machine interface company incubated in the Harvard Innovation Lab. Since 2015, BrainCo has grown from a small team of Harvard and MIT scientists to a team nearly 150 members with offices across USA, in Boston, and internationally in China. Today, he will share insights from the largest neuroscience education project in history, and the lessons learned from helping grow one of the world's largest PMI companies. Over to you, sir.
Thank you for such a great introduction. I feel like you just took care of the first few slides I was going to do. So thanks. That was great. Let me share my screen here, guys, and we'll get started. Can you guys see my slides?
Yes, absolutely.
Great.
Yes, sir.
So yeah, my name's Max Newland. I'm the president of BrainCo USA, and today I'm going to be talking about neuroeducation and the ways that we've been applying it at BrainCo. I think that intro did great justice to my background, but just to add a few little points, the first exposure I got to brain-machine interface technology was studying invasive BMI, where we're doing research on the impact on Parkinson's. And then, like he mentioned, I was also doing research with fMRI technology to investigate the impact of meditation and brain training on cognitive performance and on the structure and function of the brain using fMRI. And then after I graduated from Harvard, I joined this company called BrainCo, which has since grown to be quite a large organization. So during my talk today, I'm going to hit four main points. One is a little bit more about BrainCo, the technology that we develop. The second point is going to be about the research going on in neuroeducation in a few different flavors. And then also I'm going to talk about how we're bringing neurotechnology into schools or education settings to help people learn about neurotechnology. And then finally, I'll talk about some future directions that I see going on in the space. So really quickly, like he mentioned, BrainCo started in the Harvard Innovation Lab in 2015. And when I joined, there was about 15 people in the company. And over the past 4 years, we've grown to about 150 people, which I think makes us one of the largest, if not the largest BMI company in the world right now. We develop core BMI technology, mostly on two different platforms, EEG to understand brain signals, and EMG to understand muscle signals. We've developed applications for attention problems, education, of course. We have some centers that we're opening up in China to investigate the treatment of autism. We've developed some smart AI-powered prosthetics, and our latest venture is using neurofeedback technology to help people reduce their stress. I think we're in a moment in the world right now where that's going to be a really useful solution. So the first platform, our EEG headband. You guys can see some images here, some of the different places that we've applied it. Education space, like I mentioned. We work with some elite level athletes, including some Olympic teams in the United States, Formula One race car drivers. This is a little clip from a TV show on ESPN where elite esports athletes were using it to train their cognitive function so they could perform better. But this is one of the main platforms that we work on is EEG. The second major platform that we work on is EMG, particularly for smart prosthetics. So our team has developed the world's most affordable AI-powered prosthetic hand. Not only is it affordable, but the algorithm that we've developed allows users to control individual finger movements, which is an industry first. This product is currently being sold in China and will have FDA approval to sell it as a medical device in the United States in the next couple of months. It was this innovation that actually won us one of the top 100 inventions for Time Magazine last year. And I have a short little video to show you one of our users controlling individual finger movements with the neural impulses that we're picking up from his muscles. So you can see the dexterity that this technology allows users to have. Instead of relying on pre-programmed gestures, we can actually have users train the hand to respond to any combination of finger movements that they want. So the level of dexterity we're able to achieve is better than anything else on the market right now. We're really excited to be launching this project. All right, so that's gives you a sense of the platform technologies that we work with. Now I'm going to spend a couple minutes talking about the education side specifically. So one of the key insights is you need the right partners to really make this type of technology have the impact that I think we all sense it can have. So we've partnered with labs and publications at NASA. We published some studies with the MIT Media Lab that were really, really interesting. We've done our own research studies with schools in the United States and internationally, and also with other industry partners in the education space to understand things like student engagement, how effective different teaching methods are. For example, a lecture like I'm giving versus hands-on learning or more active learning environments. We've used this type of technology to evaluate different education technology tools and also apply neurofeedback in schools to reduce stress and increase focus to augment students' performance on tests and their general well-being. So if you're thinking about the neuroeducation space, I think these are the main topics that we've seen so far, at least, is engagement, measuring the effectiveness of different teachings or tools, and then also applying cognitive training for students to help them feel better and perform better. But the kind of holy grail for neuroeducation that's at least been in our minds for years was to use this technology to personalize education. So what I mean by that is imagine learning, and while you're learning, the lesson starts to adapt based on your brain state. So we would change things like the difficulty of the lesson, change things like how we're displaying the information. Maybe we understand that you respond really well to visual stimuli. So then we'll show you more visual stimuli to keep you more engaged, help you learn more efficiently. And then syncing that with a learning platform, so all of that analysis gets saved and the platform can be optimized for each individual learner. So this was kind of the idea that we always had, but like I mentioned before, it really comes down to the right partners. And over the past couple of years, we've found the partners to actually execute on this vision. So I'm going to show you guys a video of one of these projects that we have recently finished. And this project was with a company out of Latin America called Progrentis, Latin America and Spain. So just last year, we finished that data collection on around 6,000 students to understand how we can personalize education using learning platforms. And at the time, that was the largest neuroscience education project in history. Just this year, in fact, actually, it was just a couple months ago that we announced an even larger initiative. There's a company in Brazil called Somos, and they're the country's largest education company. And just this past month, we announced a partnership with Somos, Google for Education, and a couple other research labs in Brazil to integrate this technology into the Chromebooks that Somos uses with their million students that are on their learning platform. And just like the video that you saw on the last slide, where we're looking to understand how students learn so we can optimize and personalize education, we're going to be doing this on an even greater scale with this partnership. In addition to helping to understand how students learn so we can optimize education, we're also going to be using this opportunity to teach students how to reduce their stress so they can feel better and perform better. So it's kind of a 2-for-1 initiative where we're going to investigate the science of learning and also help improve the well-being of students all across Brazil. And the trajectory that this initiative is going on looks like it will be even bigger than the last project that we worked on. The last major category that Brainco works in terms of neuroeducation is teaching people about neurotechnology. So the previous slides were about doing research into neuroeducation, but we also develop products that teach students about BMI technology. So what we've done with the product you see in front of you is taking the principles from the real prosthetic hand that amputees use, that medical device, and we've turned it into an education project where pairs of students can assemble, code, build this prosthetic hand and have it do different types of functions, learn about circuitry, learn about programming, learn about physics and biology, and learn about neurotechnology in the classroom. So we have our real applications we have our applications for medical devices and research and cognitive training, but we also take them and convert them into products that people can use to learn more about this. And this is just starting to take off in the United States. It's a really, really exciting opportunity. And here's just a little video of what that project looks like. Our vision for this product is to connect students with a real application of BMI, that medical device that you saw the amputee using, so they can see how BMI technology can have an impact on people and the world around them. So this is a really interesting project. And we're actually expanding it this year. We are going to be building curriculum for middle school and high school and university students to code the headband as well. So they can create their own algorithms, they can learn about neuroscience, maybe even create their own applications for different types of cognitive training or different research experiments. And again, I think that this is a really interesting way to get involved in neurotechnology if you're interested. So to kind of sum it up, BrainCo works on neurotechnology in a few different ways. One of them is through the research we do with our industry partners to personalize and optimize education through neuroscience research. The second way is to train different cognitive abilities as it relates to education to help students feel better and do better in school. And then the last category is educating people about neurotechnology and its applications through those two projects I just showed you at the end, the prosthetic hand stem kit, and then also coding with the headband. If you guys are interested in any of these directions or even other ones, I really encourage you to reach out to me. This is my personal email, or if you scan that QR code, it will bring you to my LinkedIn page, and you can add me and we can start chatting. But I really hope to be in touch with more of you guys in the future, and I appreciate the time, and I appreciate NeuroTechX and NeuroTechX India for giving me this opportunity to share the work we're doing. So thank you guys very much.
Thank you, Dr. Max, for the great presentation on neuroeducation and your ideas on the research and real-time application in schools such as personalized learning were really mind-boggling and inspiring as well. Also, congrats on the AI-powered most affordable prosthetic hand. Next up is Dr. Shikhar Chaudhary. I would like to start with a quote. Good marketing makes the company look smart, but great marketing makes the consumer feel smart. Being a marketer myself, it gives me immense pleasure to welcome Dr. Shikhar Chaudhary to speak on neuromarketing. Mr. Shikhar Chaudhary is a cognitive neuroscientist, a TEDx speaker, an entrepreneur, and he is the director of the Indian division of Neurons Inc., a global applied neuroscience company. When not extolling the virtues of meditation, he spends his time lecturing at universities and bridging the gap between academia and industry. A graduate from King's College London, Dr. Shikhar specializes in research on human attention, emotion, memory, information processing, and decision making. This enables him to explore how consumers make decisions and help businesses align their messaging to meet their interests, desires, and the moods of consumers and reach their target audience on a subconscious level. He also frequently collaborates with neuroscientists from across the world to develop consumer-specific neuroscience tools. We at NTX India are very honored to have you as a speaker for neuromarketing. Over to you, Dr. Shikhar.
Thanks a lot. Thanks for having me. So let me just share my screen here one sec. Yep, so I hope everyone can see the screen here.
Yes, we can.
Okay. So let me just start out by saying, what is the need for neuromarketing altogether, basically? So if anyone here has read, for example, Daniel Kahneman's excellent book, Thinking Fast and Slow, I think you're already well aware that we have basically two modes of thinking, system 1 and system 2, where system 1 is a very subconscious, it's fast, it's automatic, it's everyday decisions that we take. System 2 is a more conscious, slow, effortful decision-making process altogether. So now, while we like to think that we as humans are extremely rational creatures and we decide everything based on after multiple decision-making in our heads, what is actually the truth is that majority of decisions that we make on a day-to-day basis are subconscious and emotional. As it turns out, about 95% of decisions that you're making on a day-to-day basis are subconscious, and they are unavailable to be understood by normal traditional methodologies, really. So like I mentioned, system 1 is extremely fast, extremely unconscious, and extremely automatic. So the difference here in traditional market research is that traditional market research tends to depend on things like focus groups, on interviews, on surveys, all of which are pretty decent in understanding your system 2 responses, basically, the surface level responses, the tip of the iceberg, essentially. But what it can't really do is understand the underlying behavioral responses. What it can't really do is understand why consumers prefer one product over another product, why consumers react a certain way to a form of advertisement, why consumers prefer one thing and not another thing altogether. So to understand those techniques is where neuromarketing actually comes in. Neuromarketing essentially uses a lot of underlying tools from a lot of different fields altogether. So consumer neuroscience or neuromarketing uses tools from traditional economics and behavioral economics. It uses tools from neuroimaging. It uses tools from behavioral psychology, as well as experimental psychology. So it's a massive field that uses a combination of a lot of different techniques, a lot of different fields altogether, ultimately to end up at an understanding of what drives consumer behavior and what motivates them to go out and purchase a product. So obviously there's multiple tools when it comes to any sort of consumer neuroscience lab, but what we basically be doing is focusing on a very few of them right now. So what we offer our clients is the added value of neuroscience. And what that essentially means is that we can provide clients the certainty of knowing what their consumers are feeling, what their consumers are thinking, how their consumers are behaving in the market altogether. There have been massive amounts of research papers that have been published on using brain mapping, using brainwaves to basically predict consumer behavior in the long term. What we find is while traditional methodologies like a focus group or a survey might be accurate about 40 to 50% of the time in actually predicting purchase intent, we find that brain mapping and actually EEG responses are about 80 to 90% accurate in actually predicting what people are going to do in the marketplace. So it helps marketers and it helps companies understand exactly how to create products that appeal to people, to create marketing campaigns that appeal to people, to create advertising that appeals to the most subconscious and emotional side of a person rather than just the surface level responses that you're capturing. So from EEG, we're able to capture a lot of interesting things, obviously understanding how people feel, obviously understanding people's motivation behavior, but also their willingness to pay, for example. So there have been massive studies that are obviously you can go through and understand that using brain mapping actually gives you insights into consumer behavior far more than anything ever could. So now what is Neurons Inc? So Neurons Inc is essentially an applied neuroscience company based out of Copenhagen in Denmark. So while we have our headquarters based in Copenhagen, we have offices all across the world right now. Canada, the US, Latin America, the Middle East, and Asia. Essentially the kind of work that we do is bringing consumer neuroscience out of the lab and bringing it into the marketplace altogether. So what we're trying to essentially do is commercialize lab-based neuroscience, lab-based learnings, and lab-based technologies, and bringing them out to the field to have it used by regular marketers, to have it used by regular companies for their own insights. So we have a massive database of data that we've collected all across the world. So we have the largest database of eye tracking data in the world, but then also we have EEG data from about 11,000 people globally. We have ads tested, about more than 500 TV ads that have been tested. We have more than 800 digital ads that have been tested. So there's a massive wealth of data that we can basically go to and not only understand consumer behavior from those resources, but then also conduct things like machine learning in that technology, go through that vast amounts of data and try to find patterns as to certain forms of consumer behavior that really can't be understood through any other methodology. So what kind of equipment do we use for this purpose altogether? So obviously there's a vast variety of tools that we use, including implicit testing, including facial coding, including heart rates, galvanic skin responses. But the main two ones that we tend to utilize for most purposes are eye tracking and EEG headsets. So for eye tracking, we use something called the Tobii Pro glasses, which is essentially, like you see here, it's a camera in the center there that is basically filming everything that the person looks at in real time. And there's sensors underneath here that basically track the person's eye movement in real time. So what the eye tracking is basically telling you is what the person is looking at, what the person misses, how long are they looking at something, how long does it take for them to navigate through a certain field of vision, what do they see, what don't they see essentially. So any attention metric that you need, you capture from the eye tracking. But what we tend to do is combine eye tracking along with this EEG headset. So the EEG headset that we use is the ABM X10 system. So it's a 10-channel EEG headset system with about 9 channels for EEG and 1 additional channel for conducting heart rate variability or EMG. So what this allows us to do is, because it's a completely lightweight and portable device, it's, as you can see, it's completely wireless and allows the participants to freely interact with their environment altogether. Because the way that the system works is it sends signals directly from the system in the back here, from the diagonal signals, and sends it by Bluetooth to the computer. So this helps us not inhibit a person to a central location and have them interact with something on the screen, have them interact with their smartphone, have them interact with a product in front of them, even have them actually walk around a retail environment, for example. So we've had people wear the headset, wear the glasses, and essentially walk around a car showroom and interact with the cars in the showroom. We've had people put on the EEG headset and walk through a retail store, look at the prices, look at the products, have them interact with their environment. It completely frees the participants to basically capture that amount of data and for us to have the liberty to basically get the efficacy that we want out of the data, but then also have the freedom to basically maybe not scare regular consumers and maybe not pin them down to one central location altogether. So what this also allows us to do is essentially test in mobile environments altogether. So I'm sure you've seen multiple sets of EEG headsets that obviously have many, many more channels. While this has only a limited number of channels, what this allows us to do essentially is ensure that the power behind it, the sampling rate is significantly high for us to capture the data that we wanted to. But then it also gives us the freedom and liberty to basically have people feel free to basically interact with their environment altogether. Because one thing in consumer behavior is very important is not to bias the consumer on the other end. So what we want them to do to be as free as possible, to be as relaxed as possible, to interact with their products, interact with an ad just like they normally would. So this system basically allows us to do this because there's an inbuilt accelerometer in this case, which allows us to denoise the EEG signal so we can have people essentially walk around a certain environment, and then we can still capture that data without a lot of interference in there. There's also an inbuilt system for denoising. There's also a system for artifact rejection, eye blink rejection. So there's a lot of data that can be basically cleared out through that artifact rejection automatically. And there's a system that we do post-testing that we also do the artifact rejection in that case as well. So what we tend to do basically is allows us to do things in a much more mobile environment. And that allows us to take neuroscience out of the lab and take it out on the streets even. So we're able to do some sort of incredible studies through these technologies. Now, the way that we do this analysis essentially is traditional EEG would normally use something called the ERP, basically, the event-related potential. So while that is a staple of when it comes to understanding any sort of brain responses, what we tend to do is use something called the FBAs, basically, the frequency-based analysis. So while ERP is good in certain contexts, what happens is to get data from the ERP, you need to show them the stimuli over and over and over again, which can often lead to habituation or sensitization. So obviously, if you're testing a regular person in a consumer lab, if you're showing them an ad, you can't afford to show them an ad over and over multiple times and expect to have the same result. You want the most immediate and honest response from the person. And that's why instead of showing them an ERP, basically what we do is basically we capture the frequency-based analysis. Basically what we're doing is capturing the different frequencies of the brain, the different parts of the brain altogether. And then that data obviously goes through multiple iterations, that it goes through denoising process, cleaning processes. And then through that, essentially we can interpret many results from that. So the metrics that we're collecting from these, because obviously the data that we collect has to be given to the marketer, given to the client at the end of the day, with a simplified understanding of what they should do with it. So the metrics that we tend to collect from this are basically fourfold here. So one of them is visual attention. That is something essentially we're getting from the eye tracking itself. So the eye tracking, like I mentioned, is basically telling us what participants see, what they don't see, what they miss, what are they looking at. All those metrics are captured from the eye tracking itself. From the EEG, from the brain mapping, what we're collecting are cognitive load, arousal, and motivation. So these are metrics that we've created and metrics that have been peer-reviewed and have been published in several journals altogether. What cognitive load basically tells us is the amount of information processing that's happening in the consumer's brain in real time. So it gives us an indication of, is the person comprehending the information that's being provided to them? How is the information processing happening in the brain while they're interacting with a piece of stimuli, for example? When they're interacting with an ad, they're interacting with a product, they're interacting with a marketing campaign. Basically, how much are they understanding and comprehending the information that's being provided to them through this ad? The emotional metrics that we're collecting are essentially arousal and motivation. Arousal, we like to define it as essentially the intensity of emotion that the person is feeling. So the emotional intensity is basically telling you the magnitude of emotion that the person feels. So are they feeling a strong emotional response or a weak emotional response? So this is the same thing that you would get from traditional biometric methods like GSR, like heart rate variability. But obviously, because we're getting it directly from the source, directly from the brain itself, we find that the accuracy of an arousal response, an emotional intensity response, is far stronger in this scenario. And the main thing that we want to get from the brain essentially is something called motivation. So motivation can only be absorbed from the prefrontal cortex essentially. So what it basically tells us is the balance of the emotion that the person is feeling. So while arousal might tell you the intensity of emotion that they feel, motivation gives you the balance of those emotions. So whether they're feeling an approach or avoidance response, or whether they're feeling basically a positive or negative response on that basis. So because we can capture this data for an entire stimuli, we can also capture the data obviously on a second by second basis. So for any piece of content that they're watching, for any product that they're touching, for any showroom that they're walking through, because we capture data on a second by second basis, we get a very fine-tuned, minute understanding of how did they feel, what did they interact with, what was the level of engagement there, what did they like, what didn't they like, everything that you want to understand, but you can't really gather from traditional methodologies at all. So those are the metrics that we're essentially collecting from the EEG. And basically what we do is all the scores that we capture essentially are normalized on a 1 to 100 scale. So it goes through a certain processing technique that basically normalizes all these scores on a 1 to 100 scale, and then there are benchmarks built into the system as well. So because it's normalized on a 1 to 100 scale, we know what numbers are basically more likely to yield positive results. Because we know if the scores are above 50, people are showing a positive emotional response. We know if the numbers are below 50, people are showing a negative emotional response. The same thing with cognitive load. We know that the optimal area for information processing in the brain is between the scores of 55 to 75. Because when we find that people show scores below 55, that means people are extremely bored and disinterested in what's happening. If people are showing a score above 75, that tends to mean that they're overloaded with information. They tend to be stressed out. They tend to be confused by the information that's being given to them. So the ideal sweet spot for any sort of communication, essentially, we basically say is 55 to 75 here. And because all these scores are normalized on a 1 to 100 scale, this essentially allows us to quantify their emotional response, quantify their cognitive response, and essentially compare it against other people within the target group. So what this allows us to do for different clients essentially is compare men versus women, for example, compare Mumbai versus Delhi, for example, compare people of a certain financial group against another financial group. So what this does is basically allows us to use neuroscience in traditional market research methodologies, but get the same kind of data, get the same kind of discrepancy, get the same kind of dissection of data that they want to essentially. So you can essentially understand how your target base is really responding, because what we can do is essentially compare them against each other using these metrics. So now where all can we use this neuroscience solution? So ideally, we call it a Pandora's box, basically, because what we find is essentially applicable across the board in any vertical that you want to understand. So we tend to use it from everything from advertising and media to all the way to product testing to retail environments, as well as a lot of innovation testing altogether. So let me just go through this one by one. Let me just give you a taste of what these actually look like. So for example, taking advertising. So advertising is the heart and blood of basically marketing altogether. Advertising is billions, and people spend billions and billions on advertising just to essentially communicate their message to the consumer in the first place. But the problem is that we find when you do research on the marketplace, about 85 to 90% of new products that are coming out of the market every year, especially in India, tend to fail massively. So it's only a thin margin of products that tend to succeed in the marketplace. Now, obviously, all those ads that have been created have gone through some sort of vetting process. They've gone through some sort of analysis. But even then, about 85% of ads that go in the market completely fail to sell the product that they're trying to do. So why is that the case here, really? So using brain mapping, using EEG, we're able to understand ad performance on a much more subconscious level, because we know that the subconscious behaviors are the drivers of actual consumer behavior. So for our clients, essentially what we're able to do is understand, for example, what within your ad captures attention. So is your brand capturing attention? Is your tagline capturing attention? Is your call to action capturing attention? Basically, how should you design the ad to ensure that every aspect of it captures the amount of attention that you want it to? Mainly understanding the emotional response to the ad. So if you get the data on a second by second basis, it's essentially understanding where are the peaks in the emotional response and where are the valleys in that emotional response. So what on screen appeals to people, what on screen turns people off altogether. Basically understand things like how well the brand is remembered. So if you do an analysis post that, you basically, through the cognitive load demand, you basically understand the amount of mental effort the person has to take in. And that's very strongly correlated to actual memory responses when it comes to these advertisements. So let me just show you what one of these would essentially look like. So here we have a participant set up with the EEG headset over here. And we have this eye tracking set up here basically, and they watch this ad on screen. And what happens is when they watch the ad on screen, you'll see eye tracking happening on the screen here. And underneath here, you'll see these metrics develop in real time basically. So what the metrics are, essentially blue is the cognitive load. So blue is basically the information processing happening in the brain. Red essentially is the level of arousal. So red essentially is the magnitude or intensity of emotion that they're feeling. And green here essentially is the motivation response, which is basically the most important thing when it comes to figuring out a person's purchase intent. So ideally, you would want for anything. So this is the 50 line here, basically. Ideally, when the green section here, the green graph, is above 50, people are showing a positive emotional response. When it falls below the 50 line here, essentially, people are showing a negative emotional response. Let me just show you what that looks like here.
They say that we Danes are the happiest nation in the world. So, what's our secret? Could it be that we find joy in nature? Is it that we keep work and life in perfect balance? Is it that we make time for hygge, feeling all fuzzy and snuggly together? Some believe the Danish way means searching for a better way. Are we happy because we create beautiful things? Often. Maybe it's choosing simple style over fads and fashions. Or could the secret of our happiness be down to creating what we believe is the best beer in the world? Probably.
So if you see this data here, basically, we're capturing the data on a second-by-second basis. So what we can do for the client essentially is isolate on a frame-by-frame basis what people are resonating with and what's turning people off altogether. And that allows clients to basically, yeah.
I apologize, but your video is not visible, unfortunately.
It's not visible.
They weren't able to see the video. I think the screen didn't move to the video screen.
Okay, wait a minute.
All right. Thank you. We're just fixing it, people. Thank you so much.
Okay, are you able to see the video now?
Unfortunately, not still.
What screen do you see in front of you?
We see the screen where you have the graph showing arousal and cognitive load, and with the Be Alert X, Tobii eye tracking device, the X, yeah.
Right. So, but you can't see the video on the right side of that?
No, unfortunately not.
Okay, that's odd. Let me just play that again. Let me know if you can see this now.
Probably you want to change.
They say that we Danes are the happiest nation in the world. So, what's our
Is it
secret?
visible now?
Oh, no, actually, it's still. So we see still image and the audio is running.
Let me just actually try one thing again. One sec.
Sure, Kaushik.
We apologize for this. I'm sure we'll have it sorted very soon.
They say that we Danes are the
any
happiest nation
luck
in
now?
the world. So, what's our secret? Could it be that we find joy in nature?
I mean, it's working on my end, so I'm not entirely sure why you can't see it.
Is it that we keep work and life in perfect balance? Is it that we make time for hygge, feeling all fuzzy and snuggly together? Some believe the Danish way means searching for a better way. Are we happy because we create beautiful things?
Okay, so let me just go to the next slide. Then are you able to see the next slide now?
No. So your screen sharing is actually stuck. So if you can stop sharing and then start sharing
Okay,
again,
sure. Just right.
that would help.
Okay, can you see it now?
I think there's a slight lag. So it says you started screen sharing, but we can't see anything still. It says double click to enter the full screen mode. So
It is
Can you
in the
try-
full screen mode, actually, yeah.
They say that we Danes are the happiest nation in the
Can you
world.
see it now?
So,
No, actually, we don't see the video right now, but we hear the audio. So.
Oh, okay. Okay, so that's strange.
do you, if it's okay with you, if I may suggest, if you can share your slides with, say, one of us, we will cast them from our end.
Could it be that we find joy?
Sure, no problem. But let me just go through the next few slides. So are you this is the next slide here?
No, unfortunately, we can't see your entire presentation. That's gone off.
Dr. Shikhar, could you do that again? Just stop screen sharing and again start it, maybe.
I mean, I did try that. I mean, I can see everything from mine. I don't know what the issue is.
So attendees, we're really sorry. We'll make sure the video reaches all of you.
Okay, so you have to start screen share and say next slide. Can you try doing that?
Just try sharing it this way. What about now? Can you see it now?
No, unfortunately. You have shared your slides with
Yeah,
the
maybe
right.
Yeah, maybe I'm downloading it right now. So maybe I'll share this once it's downloaded. Yeah, sorry for the delay.
No, but I'm not sure what the issue is because I can see it's saying sharing here. So I'm not entirely sure what the issue could be. Was it visible the first few slides at least?
Yes, everything was visible up to the video. Karthik, I think Brian is sharing.
Okay, then fine.
Yeah, because he's got better bandwidth. So he'll be able to. In the meanwhile, can I please remind you all about our fantastic NTX social media challenge? Please use our hashtags NTX, Namaste NTX India and NTX Goes Desi. Comment on your social media post, on your social media handles, and we hope to definitely pick on the ones who get the most likes and comments, and there'll be some interesting NTX swag for them. In the meanwhile, can I please remind you all about our fantastic NTX social media challenge? Please use our hashtags NTX, Namaste NTX India and NTX Goes Desi. Comment on your social media post, on your social media handles, and we hope to definitely pick on the ones who get the most likes and comments, and there'll be some interesting NTX swag for them. In the meanwhile, can I please remind you all about our fantastic NTX social media challenge? Please use our hashtags NTX, Namaste NTX India and NTX Goes Desi. Comment on your social media post, on your social media handles, and we hope to definitely pick on the ones who get the most likes and comments, and there'll be some interesting NTX swag for them. In the meanwhile, can I please remind you all about our fantastic NTX social media challenge? Please use our hashtags NTX, Namaste NTX India and NTX Goes Desi. Comment on your social media post, on your social media handles, and we hope to definitely pick on the ones who get the most likes and comments, and there'll be some interesting NTX swag for them. In the meanwhile, can I please remind you all about our fantastic NTX social media challenge? Please use our hashtags NTX, Namaste.
We're really sorry for the technical problem. We're really sorry. We are sorting it out soon. Brian, are you sharing the screen? We are starting it out soon. Brian, are you sharing the screen? Yeah, it's on the display right now. Presentation.
Yes, could you go to the next slide? Yeah, so can everyone?
We are starting it out soon. Bren, are you sharing the screen? Yeah, it's on the display right now. Presentation.
So can everyone see the screen over there?
Yeah, yes, Dr.
Yes, could you go to the next slide? Yeah, so can everyone?
We are starting it out soon. Bren, are you sharing the screen? Yeah, it's on the display right now. Presentation.
So can everyone? Yeah, I think videos. I can't make a. The video is constantly in loop. That's yeah.
Yeah, I think something's getting looped up here.
So we'll just get it sorted. Sorry for the technical problem.
Try something.
They say that we Danes
Yeah,
are
is
the
this link
happiest nation in the
now?
world. So,
Yes, Dr. Shikhar. It's going good.
Okay, good. Okay,
could
so
it be that we
let me
find
just, sorry
joy
about the
in
interruption.
nature?
Let me just quickly go through this again.
Is it that we
Like I
keep
mentioned,
working
again, you're here
at
on a
life
second
in
by second
perfect
basis. You're seeing the
balance?
response in real time, basically. So you're seeing the cognitive response, you're seeing the emotional response, you're
Is it
seeing the
that we
arousal
make
response in
time
real
for
time, basically.
hygge,
And what this helps us
feeling
to do is
all
basically
fuzzy
is
and
understand
snuggly
on a
together?
frame by frame basis what really works and what doesn't
I
work,
believe the
and then
Danish
basically
way
provide
means
recommendations to the
searching
client
for
to
a
create
better way.
advertising, basically that
Are
appeals to
we
the most number
happy
of people and
because we
appeals
create
to subconscious elements
beautiful
of people
things?
altogether. So obviously we can do this not only in a TVC format, but then we're also doing it on, for example, digital marketing. So obviously a lot of social media marketing. What we tend to do there is basically we work with a scientist based out of Stanford University. And what we did was we evaluated 4 different criteria that any digital marketing campaign actually needs to hit. So one thing that we measure is something called stopping power. So when you are scrolling through your Facebook, you're scrolling through Instagram, essentially, what causes you to stop at a particular ad, for example? What causes you to spend time with an ad at all, essentially? Other thing we're basically measuring is something called transmission power, which is basically when you do observe an ad, what is the level of processing that's happening? How much do you understand the ad that you're watching? How much do you comprehend and remember the ad that you're watching? The third thing that we want to look at is the persuasion power, which is basically, does it engage you enough? Does it basically draw that emotional resonance in you? Does it make you feel something or not? That is the persuasion power that we're measuring. And locking power essentially is something that we're looking at post-testing. What is the memorability of the ad that you just saw? How well do you remember what you saw in the past? So we did a study for Mobile Marketing Association, and what we found in the brain essentially was that shown a certain number of ads, within 100 milliseconds, 5% of the ads start resonating with the brain. So the brain starts identifying that they're watching an ad within 100 milliseconds itself, or 5% of the ads. Within 200 milliseconds, 25% of the ads are being noticed. Within 400 milliseconds, about 67% of the ads are being noticed. Within a 700 millisecond mark, the emotional and the cognitive response in the brain starts to form. And we can basically start measuring these in about 700 millisecond responses. Within 1,000 milliseconds, almost 50% of the ads that the people are interacting with are producing some form of emotional response, be it positive or negative. And within 1250 milliseconds, basically the cognitive recognition is happening and you've identified and responded to an ad altogether. What we find from this research essentially is that people spend no more than 3.4 seconds on an average with any mobile ad altogether. So that puts marketers in a conundrum, mainly because they have to design ads that basically capture people's attention in the first 1 or 2 seconds, essentially, or they lost the consumer altogether. So it's understanding how to create a communication which in the first few seconds captures you attention, it captures you cognitively and captures you emotionally, is something that we tend to work with clients like Facebook, clients like YouTube, clients like ESPN, Yahoo, everything, to basically understand how to draw participants in, how to draw consumers in, and basically hold their attention throughout their entire content. Other things that we want to understand is what happens with the level of stress. So obviously when you spend time on YouTube and you spend time on other things, you obviously notice a buffering response from time to time, essentially. So we wanted to understand how cognitively stressful is that buffering response that's happening in the brain. So what we did was we measured the amount of stress response while a video is buffering on any particular platform. And we measured the same sort of cognitive response in terms of when people are doing a math equation, for example, or when people are watching a horror movie, or when people are standing on a great height, for example. What we find is the level of stress that the person feels while something is buffering or while something is taking a long time to load is equivalent to the same amount of stress that they feel while watching a horror movie. So the level of stress is significantly high across the spectrum, wherein people become extremely stressed out. They show extreme amounts of stress response just due to the buffering of certain things happening. And when you look at the emotional engagement happening in that context, the content that they're meaning to watch is tended to enjoy much less, because post-buffering, the amount of investment that you have, the amount of engagement that the content has, tends to fall significantly. And also the brand equity that tends to happen over time tends to fall significantly in that response as well. So this is a study that we did with Sony Ericsson, that if you just Google it, you'll find a massive, I think about 20, 30 page long paper on the topic as well. So it's a very popular study that we've done. Apart from that, we've also done a lot of studies that basically involve testing engagement with forms of communication across different media, for example. So for Canada Post, for example, we tested how does communication on physical media compare as opposed to, say, digital media. So what happens when you read information on a physical piece of paper or a magazine, for example, as opposed to when you watch the same thing on a smartphone, or where you watch it as a banner or on your computer, or if you read it in an email, for example. What we found from this is basically that physical media requires 21% less effort to understand and has a 70% higher brand recall. What this says basically is that digital media shows far stronger cognitive demand. So digital media requires 21% more mental effort for you to put in to basically understand the same amount of information that physical media could give you. And the brand recognition and the brand recall is 70% higher when it comes to any sort of physical media, as opposed to when you're doing it on digital media or any other social media platform. I'm just going to go through this quickly. And also we do obviously a lot of testing for different A/B testing. We do a lot of UX UI testing when it comes to e-commerce evaluation. Basically understand how websites are functioning, understanding how certain apps are functioning altogether. Let me just show you what that would look like. I hope you can see this video here. Please let me know if you can't see this video as well. So here, first of all, you'll see what the setup essentially looks like. So first of all, obviously you would set up a participant with the ABM that I mentioned, the brain mapping headset. Following that, what we do is essentially set them up with the eye tracking glasses. So obviously you would calibrate and benchmark both the processes. And then now you would essentially give them the app that you want to essentially test in this case. So the red circle that you see there, obviously that's the eye tracking in real time. You're basically looking at what the person looks at. And underneath you see the EEG metrics happening. The same thing as the ad that we saw, underneath you see the metrics happening. So you see the cognitive load, you see the motivation arousal in real time. You get a second by second understanding of their perception of the brand and this user interface that they're interacting with. Apart from that, like I mentioned, we work a lot in advertising and media, but then we also work a lot with FMCG companies like ITC, like Unilever, like Marico. And what we do is we basically use brain mapping to essentially understand responses to different forms of packaging that they're creating, or responses to different forms of sensory neuromarketing when it comes to product interaction. So what happens when a person looks at products the first time? What happens when they touch it, when they feel it, when they smell it, when they taste it. All of those elements have a part to play, and they basically lay out how you basically look at the consumer journey altogether. So one thing that we look here to understand is basically how does packaging play a role in that. And one study that I can show you in that case is something that we did for Coca-Cola, when what we did was we tried to evaluate how does their signature glasses basically play an impact as to how you perceive the product altogether.
We now have
If you
conclusive
Coca-Cola
scientific
in
proof that
regular
signature
glass as
glasses
opposed to one
deliver
of
the
their signature
perfect
glasses,
serve.
does that have
Global
a
glassware
difference in
giant
their response to a
Pazabache
particular
commissioned
brand?
leading global market research specialists Ipsos, together with applied neuroscience company Neurons Inc., to conduct neurological research, seeking to establish if and to what degree there is a conscious as well as unconscious improvement in user experience when consuming a beverage using a signature glass.
The subjects were asked to drink Coca-Cola from different non-branded, branded, and signature glasses. We used EEG and eye tracking to measure unconscious reactions throughout the drinking experience. This controlled process and methodology allows a close understanding of subject responses from both a conscious and unconscious perspective. Eye tracking measures visual attention. It tracks exactly what subjects are actually paying attention to. Electroencephalography, or EEG, is an electrophysiological monitoring method to record electrical activity of the brain. EEG technology allows us to amplify the microelectrical impulses between neurons in the brain. EEG uses electrodes placed in particular locations on the scalp that then set looking at, as well as how
Glass or branded generic glass, the emotional engagement, functional appeal, visual appeal, appeal to own and willingness to pay all rank highest. Simply put, signature glasses deliver the perfect serve.
Apart from this, obviously, like I mentioned, we can do things within the retail environment as well. So you're not situated into a particular lab setting. You don't have to put participants in a central lab and test them then and there. You can set up participants and have them, for example, walk through a store environment and have them interact with their environment, see what they see, how to interact with prices, shelves. So I think you get a sense of the retail environment that we tend to test. So one thing that we also use this to understand is, because we can test in real time, we can understand how people are responding in a retail environment or in a grocery store, for example. And then using the motivation responses, using the cognitive demand responses, we can actually know before the participant even knows whether they're interested in the product or not. Let me just show you an example of what that looks like. So the blue line here gets cognitive demand and the green line is the motivation. So when there's, you see here, when the blue line is above a certain level, there's a high level of stress response in the store environment and they're interacting with the environment here. Ideally, when the motivation response, the green line is above the central line, the 50 line, they tend to be positively oriented towards the product that they're looking at and they tend to buy the product. But obviously, in many cases, when the motivation response is falling below that particular line, we know before they even know that when they look at a product, they're not going to purchase that product at all. It's a real-time understanding of consumer behavior that can't really be understood through any other methodology in this case. Let me just go through a few other studies quickly. And basically, one of the studies that we did for Facebook, for example, is understanding how people respond to newer technologies like virtual reality, for example. So Facebook had just recently bought out Oculus. And what they wanted to understand was when people communicate with each other through virtual reality, does it feel the same way? Do humans interact with each other? Does it resonate the same way that you would as interacting with the person face to face? So what we did was, obviously, we tested participants while they were interacting with another human being face to face. And then as well as we put them in virtual reality with the EG headset on, and we measured their emotional engagement while they were resonating and talking to an avatar of another person. So what that gave us is basically an understanding of what people perceive in another person, what people resonate with, and what doesn't work. So what this helped us to understand is basically give Facebook certain guidelines into understanding how to basically get out the pitfalls that are actually happening, that uncanny valley of having difficulty in understanding how to comprehend another person on their screen, and basically help them make VR far more effective and make it far more engaging in many manners. And I think the last thing that I really want to go through quickly essentially is a study that we're very proud of. So this is a study that we did for Spotify India, which you might have actually seen on TV as well, because this was an ad campaign that ran, I think, a few months ago. And what we did here was Spotify came to us and wanted to launch in India. And they wanted to understand how best to create a marketing campaign that resonates with the most number of people, essentially. So what they did was they gave us a bunch of songs to test. We tested all of those songs, and then we found a certain section of song that essentially that engaged the most number of people, essentially. And what they did was they basically created a marketing campaign around their entire campaign.
India releases over 100,000 music videos each year, 2,500 hits. The rest misses. That's a 0.025% chance of a hit. So, for Spotify India's launch music video, we didn't leave it to chance. We made a musical hit with math. The beat of a billion. The hunt for the rhythm that has the greatest probability of a hit. We started by making a playlist of India's top hits, songs from multiple languages and different genres, and made a mixed group of people listen to it. As they listened, we monitored their brain's reward system, fishing out parts that spiked their interest. We then ran all the liked music samples through an algorithm that highlighted patterns, beat progressions, instruments, and other commonalities. This data was rehumanized by ear to pick out the most recurring beat. This beat. We called it the beat of a billion. The beat became the backbone of our track, and Mickey wove his magic around it with more elements from the data, including the classic vocal mnemonic, duck, duck, duck. Let's hear it again.
I wanna feel that bass. I wanna see you shake the room. The beat goes.
Basically, all I wanted to mention, so we have clients all across the world, ideally. So like I mentioned, it's applicable from everything from advertising and media clients to everything from FMCG and product retail clients, all the way to tech companies, all the way to innovation companies. So it's essentially a thing that almost every company on earth can use in some manner or the other. Yep. Thank you.
All right. Thank you so much, Dr. Shikhar Chaudhary. We really apologize for the minor technology glitch we had, but we all seem to be back. I want to thank you, Shikhar, for a truly insightful talk on the application of neurotech to our everyday lives, especially from the point of view of both consumer behavior, product engagement, and branding and marketing strategies, which you took us so beautifully through. Both as the audience, and some of us are also service providers, so from like their viewpoint also. Your example of stress was so extremely relevant, as we just saw in today's today's Zoom call too. Everybody was just up in arms. What do we do? So because of our continuous engagement with digital media, we are continuously encountering different kinds of stress, whether it's physical world stress or digital media stress. I'm sure many of us have questions about the current day practices, and so we'll definitely find your personalized approach something to, I guess, definitely think about, and we do hope for, wide scale implementation of this in the very, very near future. All right, with that, I'm definitely excited to be here on day one of our event, Futuristic Trends in Neurotechnology. It's wonderful to see the number of attendees we have. We've gone above the 120 mark. It's fantastic. 135, I think, is where we reached at one point of time. It's really, really exciting, given the fact that we have had the chapter in India for only 2 odd months. The excitement in the community is so evident by the kind of buzz that we have been able to create over the past few days and the past few weeks. And of course, our social media handles have been completely alive with all your posts, comments, feedbacks. Thank you all so much for that. It's only because of you guys who's, this fantastic audience that we are here where we are today. I'm Sohela Kapoor. I'm the chapter advisor for NeuroTechX India. I'm passionate about all things like neurotech, so it's a perfect event for me, and I hope for you too. And I'm really glad to be hosting this today. We are really eager to, engage more with our speakers and address this multitude of questions we've had pouring in. A couple of rules for the event. Since we have today and also tomorrow, we're going to be covering a broad range of topics, given how broad neurotechnology can be. We've already seen today with our talks on, health, marketing, education. We'll try and focus on very specific details related to the nervous system, to BCI techniques, and to neurotech techniques, especially from these 3 fields. This is not necessarily just a lecture. The audience is a part of this as much of this event as the speakers. So I really urge you all to please, if you haven't already done so, post your questions, your comments, any papers relevant to this, product related information. Please share them with us in the Q&A section and in our chat section. Please do post on our social media handles, on your social media handles, using the hashtags Namaste NTX India and NTX Goes Desi, and do take part in our social media challenge, where posting your most insightful comments, so that we can create a stream of awesome resources related to the event, and anybody interested can very easily find them. And as you know about the social media challenge, there is some fantastic NTX swag which is up for also grabs for whoever gets the most likes and the most comments. We'll be also very soon posting information related to joining the NTX India chapter and to the NTX and the NTX India social media handles. Before my very able team is collating all your questions, while they're doing that, let me just bring in Karthik for a moment. He has some very interesting information to give you about tomorrow's session, and then I'll take you through another small journey about NeuroTechX.
Yeah. Okay. Thank you so much, Sohela. Yeah, I'm here. Okay. So first of all, thank you so much for the wonderful session, Dr. Shikhar. It was very, very exciting. And one more, we apologize to the attendees for the technical errors. Yeah, but I think that the loop was also sometimes interesting. That loop that we had during the technical error. I enjoyed it actually. So sorry for that, and we'll make sure we have a comfortable experience and we sorted out the bugs so that it doesn't happen in the dream tomorrow's presentation. And one important thing that I thought of sharing it is, so Dr. Shikhar, I don't know if you would have seen it, there were a lot of wows in the chat section when you showed the Spotify thing, and a lot of people really enjoyed the session. And one important notice that I would like to give the audience is to check out a course on Coursera called Introduction to Consumer Neuroscience and Neuromarketing by Thomas Jürgen Ramsay, who's actually the founder and CEO of Neurons Inc. I've gone through that course. The course is completely outstanding, and you'll get a lot of insights from that course. If you really wanted to learn neuromarketing, start with neuromarketing. I would strongly suggest that course. That's my note, and I'll hand over the stage to Sohela. Thank you so much.
All right.
I'll drop the link in the. I'm sorry. I'll drop the link in the chat section so that you can get to that course. Thank you.
Great. I'm just going to start my screen share. So like I mentioned, while my very exciting, interesting NTX colleagues collate all your questions, I am, sorry, I'm just trying to figure out. Sorry, Karthik, can I share my screen?
Yeah, I think you can, yeah. I think no one's sharing the screen, then use it.
Yes, okay. No, it says host disable attendee screen sharing.
No, I think, could you try it once, Brian? I think Brian will do that. Could you try it once more?
Hello, everyone. Brian Jenkins here. Thank you so much. I'm just reporting in from behind the scenes here as we finish up our questions for the panel. So Haley, just quickly, you have co-host permissions, so you should see a share screen button at the bottom of your window, and away you go. Happy to help if you need anything else.
Okay, I see my screen. Perfect now. Thank you so much, Brian. Can everybody else see my screen also?
Yes, it is visible. You can
Is
go
it in
ahead.
the full PowerPoint mode?
Now, could you put it on slideshow? Now it's not in the PowerPoint.
Okay.
Perfect.
Okay. Perfect. Just,
yeah.
Sorry. It's going to. Okay. So like I said, while my very able team puts together the questions, I am just going to take you through a very short journey about, NTX, the global community that we have here today. Again, reminding you, the hashtags for today's events are Namaste NTX India and NTX Goes Desi. Please do use them while you're posting. We want to collate all these fantastic resources and put them together. So NeuroTech is this international neurotechnology network. We were founded in the year 2015 in Montreal, and we have since then expanded exponentially internationally. We are basically an international community that helps in the facilitation of advancement of neurotechnology. We help in both education and promotion of neurotechnology. We were started by our founder, Yannick Roy, who will be there tomorrow. The three main pillars on which NeuroTech X really resides is our pillar of community, which is all of us here today. Bringing everybody together is one of the biggest attempts of NeuroTech X. The second one is, of course, education. We really want to be very strong, proponents of spreading strong educational material, both in the form of knowledge and also technical know-how, know-how in the form of software development modules. We have a lot of hands-on training courses, and that's one of our very strongest forte. Our third pillar is, of course, innovation, where we strongly believe that once individuals have been, brought together and they have been given the correct know-how, we can then help connect them all together and really help them make a true impact in the real world scenario by either opening up their own companies, startups, joining some other companies, and making a true impact. As I said, we have grown exponentially. Today, we have more than 25 chapters worldwide. Our latest edition has been Zurich and NTX India, which was, of course, set up only two odd months ago. We really enjoy hackathons. We love bringing together coders and developers. We have a lot of online events. Our meetups are always, buzzing. Along with that, we do also engage with several bigger organizations to hold larger events. But what we really enjoy are these very casual, small, events where there's a lot of personal interaction and people can be actually brought together to have these very open and free, engagements. Our initiatives, which come from these three pillars, are really the NTX Slack community. All of us are here pretty much because of that, because of Slack. We have more than 5,000 online Slack community members. We really encourage people coming together. What we've really seen on the NTX Slacks is that everybody comes together in, a general channel. They find very like-minded people, and then they start having very focused one-on-one conversations. The NTX chapter initiative, as I've said, is again our forte. It's really about connecting local people to the very international fraternity, as we're also doing here today. The NTX education platform, it's this fantastic open education platform, which I've already talked about. We really want to democratize neurotech knowledge and neurotech based information. The NTX student clubs want to focus on bringing very young undergraduate students very early on into the community, helping them engage with senior professionals and helping them develop their interests better and stronger. And the NTX recruitment services, it's one of our latest additions also. We have a lot of of amazing talent out there. I'm sure all of you are such fantastic scientific neurotech enthusiasts. We have companies looking for all of you guys. So the NTX recruitment service really helps in bringing these, two different entities together through our fantastic network. We also provide consulting services, financial consulting services for various startups, projects, companies, products, etc. Along with that, we have the NTX store, where you can get some fantastic NTX, like Neurotech's hardware at very good prices, and also super cool NTX merchandise. Our NTX social media channels are also very alive. We love to keep posting about different events happening worldwide, different neurotech related projects, research going on, papers, publication. We really want to keep the community informed about what's happening in the neurotech world. The NTX Content Initiative, which is our monthly news like letter, and our blog is also something which is being actively worked on. We are continuously churning out fresh material for your uptake, talking about different research projects going on, different scientific studies going on, different startups, marketing, and all of that. And finally, the NTX Buzz in Review series of events, which happens once in a year in January, where the NTX chapters really get together to try and give a whole annual, summary of what's been happening in the neurotech world to their respective chapters. So we really want to keep everybody on the same page and keep them completely up and informed about what's going on in the neurotech world. What's been super exciting is that Neurotech X launched their book. We were continuously being asked so many questions related to neurotechnology, so we decided to compile all of that into this fantastic book. It's got a broad range of subjects, so it's definitely there. It's a beginner's guide, but at the same time, since it's so broad and so comprehensive, people who are also advanced in the field will also definitely benefit from that. I just wanted to show you our NTX job board is always lit up with fantastic job opportunities. It's updated every single week, so any of you who are interested should definitely go and visit it, and you'll definitely find some very, very, very fun opportunities for you there. Finally, we've been really fortunate to have been published to have got the attention of several fantastic scientific journals and magazines. And to end with the ones who love us the most, our partners, our supporters. They have been fantastic in supporting us through this entire journey. We love them for that, and we thank them and have deep, deep gratitude to them. So without any further ado, let me just say, please do stay in touch with us. If you have any questions, reach out to us at info@neurotechx.com. And I think with that, my presentation is pretty much over. I would request the speakers to please turn on their videos, and we can move into the Q&A round. Can I also have on the screen? Okay. Dr. Naveen Gupta, can we have your video on? It really inspires our audience to see you and to feel more connected with you. And also, Dr. Shikhar, if we can have your video on. And can I please request all three of you to also unmute yourselves? All right, thanks so much, Max. I think one of the questions our audience is really keen to know about is, and I would say this is for all three of you, and only if you're very comfortable sharing this, if you can please share the software and the hardware which you are currently using, a few of the more details regarding the kind of channels, the number of channels, the software requirements, the kind of measures you're making from that. So if I can start with you, Max, if you want to get into a little bit of detail about the kind of hardware which you're currently using.
Sure. So on the EEG side, our first product is a 3-sensor wireless EEG device that's using one channel with an extra ground electrode. The innovation that we made is on the sensor itself. So we're not using metal sensors, and we're not using any electrode cream or anything like this. We've actually created our own formula for a hydrogel electrode. So it's what's considered a semi-wet electrode. It kind of feels like the pad of your finger, and you just put maybe 1 drop of water or just wipe it with a wet cloth, and you can get a really, really good raw EEG signal from it. We compared our raw signal to, you guys might be familiar with GTEC, the GTEC 16-channel Nautilus device, and we had over a 95% raw signal correlation match through a really simple protocol: eyes open, eyes closed, jaw clenching, slow blinking, and fast blinking to see the raw EEG signal. And we compared that against some other consumer EEG products as well. So the raw EEG signal is really high quality, even though it's a single channel. And in addition to that, the algorithms that we produce for our products are not based on traditional frequency bands like alpha and beta and theta and things like this. We saw and felt that those algorithms based on the frequency bands are only taking into consideration 4 to 6 features. So what our algorithms do is look at anywhere between 800 to 1200 features in the raw signal per second. And we've developed some machine learning models to quantify different cognitive states. Primarily, we're focused on quantifying high cognitive engagement or high cognitive workload, and also states of relaxation or meditation. And these 2 cognitive states are the ones that we kind of base our applications around, partially because those are cognitive states that we can reliably measure. So we want to make sure that we're basing our technology or our applications around this. On the EMG side, for the prosthetic, we're using a 8-channel EMG sensor setup, and we have a novel process or novel algorithm for understanding the impulses sent from the brain to the muscle signals, and that's what allows us to get better resolution or dexterity on the prosthetic hand than what else is available on that. There's a certain way that we go about doing that signal processing that we kind of keep secret. And then the last thing I'll mention is we're coming out with a new hardware device, EEG hardware device, that should be launching in the next couple of months.
Perfect. Thank you so much. Dr. Naveen Gupta, would you want to elaborate a little bit more about your hardware details, please?
Yeah, sure. So we're using a Smarting Mobi EEG device. So we actually are using it with the concealed EEG ear electrodes. So the main advantage of that is it's not conspicuous like the cap, which most of the systems use. So there's a bit of possibility of the subject going around and doing his normal work. And also the number of channels is 26, but the ear EEG is 10, if I'm right. So the data from the ear EEG at the moment seems to be comparable to the traditional conventional app-based EEG systems. So we hope to make it tune it for epileptic patients. So that is the application we are working on for. So apart from that, I think I would suggest others also to explore concealed ear electrodes if the application suits it.
Yeah. Right.
Thank you.
And Shikhar, I think it'll be fun. Yeah, great. Thank you.
Sorry, I didn't catch the question. Could you just repeat the question again?
Yes, we were just trying to figure out a few more technical details about the kind of hardware which you are currently using in terms of number of channels and other stuff like that. If you're comfortable sharing that, please.
Sure. So I think I already shared that within the presentation. So basically, we're using an ABM XM system. It's essentially 10 channels, so 9 channels for EEG and 1 additional channel if you were to do heart rate variability or EMG, essentially.
Yeah. Okay, great. Thank you so much. I am going to quickly move on to Dr. Naveen Gupta. I'm sorry. There was a lag.
Sorry, can you hear me?
Sorry, we could hear you, but there was a lag and your voice went off and we weren't sure.
Okay.
I wasn't. If you could please, if you could just continue, it would be great.
Okay, so basically, we use an ABM XN system essentially, and it's a 10-channel system with about 9 channels of EEG and 1 additional channel. And it's essentially, you can look it up, and they provide EEG headsets for neuromarketing, but also provided for sleep studies, also provided for healthcare. So it's a broad spectrum of clients that they essentially have.
Sure. Right. Thank you so much for that very detailed response from all the three of you. Dr. Naveen, since I know that you have to drop off soon, I'm going to try and focus 1 or 2 questions on you and then move on to Max and to Shikhar.
Sure.
One of the attendees, Gagana, who's on Zoom, they were very keen to know that you did mention preterm babies have about 25 risk of like psychiatric disorders. How exactly are you proposing BCI could help tackle this kind of a problem? Where is BCI coming in here?
Okay, yeah. So let me make the presentation clear. Preterm research was actually another parallel track, so it was actually not linked to the BCI. So preterm research we are doing so that early clinical intervention can be taken care of. So anyone who is preterm born sort of may have cognitive deficits or cognitive disorders early on in their life. So the main idea is to see which, non-invasively from their structural MRI, who are the candidates who can possibly have cognitive disorders, so that early clinical intervention can be taken. So exact, application of BCI at the moment, possibly not. BCI, it is sort of can be used for stroke and other, neurophysiological disorders, but not for preterm born. Preterm born can be possibly like clinical interventions and possibly medications. So that's the basic idea of that research, early intervention.
No, that's true. I thought I saw so many interesting applications of your BCI research, especially in like paralyzed individuals, in like stroke patients. So that's absolutely fascinating. And I think there are very, very far-reaching, implications to that. I'm going to direct one more question that has come in for you. The attendee says it's fascinating that you could obtain clean EEGs during, motion from like near the individual's ear. Do you do some kind of a blind source separation, or is it just absolutely powerful hardware, or are you utilizing some kind of signal processing technique, some kind of specialized signal processing techniques?
Yeah, good question. So at the moment, we are focusing on low power algorithms. So at the moment, I don't think ICA and blind source separation is possible. So the main idea at the moment is compatibility of the smartphone with the concealed ear EEGs. And we just managed to sort of integrate camera as well. So that's one thing which we have done. So at the moment, pre-processing, as such has not been done for smartphone based BCIs. So we are working towards it, but as you know that it's pretty challenging. doing pre-processing and sort of making sense of the data on a smartphone will be a challenge. I think that's probably the way the research community and the future is for.
Yes, absolutely. I think that's very, very crucial, and we should keep that in cognizance. So I'm going to open up one more question for the three of you. There are lots of questions on how BCI in these domains will help individuals with learning disabilities, such as autism and other NDDs. Max, would you like to start with commenting on that, please?
Sure. I think it's important to start by saying the existing research is leaning towards the probability of being able to help these people. It's certainly not definitive, though, and I think it's important to understand where the current literature is. From our side specifically, we've done research studies with people that have attention deficits, and we're able to see a statistically significant reduction in their symptoms after about 8 weeks of cognitive training. My stance on this is I think in large part those symptoms were mitigated by the stress reduction and mindfulness related practices associated with our intervention. So our intervention used mostly relaxation based neurofeedback principles to help people learn how to reduce stress and improve well-being. My best guess is that was in large part the driver for the changes we saw in emotional well-being. I think the same will probably be true for people with autism spectrum disorder or who are on the spectrum. And learning how to manage their own stress would probably drive a lot of the clinically significant outcomes that we'll see. Right now, though, no one is claiming to be able to treat ADHD or treat autism. I think the best we can say is there's a good amount of data that suggests certain types of BCI-related practices, specifically neurofeedback, can help reduce some of the symptoms associated with these conditions, particularly the symptoms associated with stress.
Shikhar, I think I could, ask you the same question. How do you see eye tracking and, EEG coming in together to try and alleviate stress levels in people with, different like developmental disorders? Do you have any take on that? Of course, from the point of view of them, actually working in, a real life world scenario.
So essentially, I feel like neurofeedback is definitely the best course forward when it comes to that, because I've actually been trained in neurofeedback as well. So I've been certified in the US when it comes to neurofeedback. So my first few years into neuroscience essentially was in the clinical realm altogether. So I was working essentially with the neurofeedback, and I was doing research on neurofeedback essentially. So I feel like that is the best way forward when it comes to, like Max said, not maybe curing people of that, but at least alleviating symptoms to a certain degree that they can basically function on a day-to-day basis far better. So there has been a wealth of research when it comes to neurofeedback, especially using brain mapping, using BCI, when it comes to alleviating people of those symptoms so that they can essentially function better in the long term. So I feel that is the way where it's going to go. Eye tracking it's more in the research field, but I don't feel like it's actually useful for benefiting people in the health field altogether. At least so far it's not.
Right. Thank you so much. And Dr. Gupta, would you want to add any further? We've heard a fantastic session from you specifically for, health-related challenges. If you would want to elaborate a little bit more on that.
Yeah, to add on to Max and Shikhar, I would say apart from EEG, the other modalities also could be explored. So there is MRI, which is sort of gives you a more perfect clinical biomarker. So that is one other thing, but of course it's more expensive when compared to the EEG systems which are available. So, at least in clinical practice, I've seen working with clinicians, they prefer more of MRI based scans to take decisions. So, neuromarketing and other applications for healthy people, I think EEG is sort of the way forward. But when it comes to clinical practice, I think MRI is sort of a better clinical marker along with EEG. So that's my sort of take on it. Yeah.
Absolutely. A lot of potential in that. The combination of all these techniques, whether it's MRI, EEG, FNIRS, eye tracking, GSR, they all really have to come in together to be able to actually contribute to better health outcomes for individuals. Right, Max, I have two people asking the same question of you. They're very impressed with what BrainCo has been doing in the space of neuroeducation. What they really want to know is what do you see as the future? How can these techniques be deployed in India? And, both of them, Girishma and Dante, say, how can we become a part of BrainCo to do some sort of education, research, neurotech education kind of research? So, firstly, how do you see this coming to India, which is going to be a huge contextual change? The way we have multitude of languages, cultures, castes, communities. So adapting it to the whole Indian scenario. And of course, they're very keen to know how can they also join, BrainCo. So if you have any thoughts on that, I'm sure they'll be really happy to hear that.
Sure. So, we're working with one partner right now in India to better understand how we can, like you're saying, localize the technology and the applications. And the way I see it, it kind of maps to the three topics I talked about. So one is the personalization and optimization of education. I think that requires local research to be done. So with Indian-based learning platforms and our technology to understand how we can personalize education at the most basic level. And this is what the paper we published with MIT found, is if you can give people real-time feedback when you detect low engagement, and that could just be a little notification on the learning platform, or maybe the lesson shifts in a slight way, just a slight little notification to the learner themselves. So it's a personal notification that can re-engage the learner, and there was really massive improvements in learning outcomes. So one is the optimization, but I think that requires local research. The second is through using neurofeedback and different cognitive training for improved well-being in education. So maybe in school settings, or I imagine there's probably opportunities in after-school training centers. And then the third is through education. So, if there are opportunities to teach students in India about BMI or BCI through some of the tools that we've developed, I think those are the three categories. And I'd be happy to meet with anyone on this call. I'm hoping that we can get them my contact information, and if they send me an email, I'd certainly follow up with them.
We will definitely share that with them. And I think people will be definitely reaching out to you on LinkedIn, on email. And I would urge all of you to definitely get in touch with all the speakers and ask your questions, get your clarifications, and maybe that you have fantastic opportunities with them. Shikhar, if I could also ask you the same question. You've been doing such an amazing research, and I think Spotify was absolutely cool. But how do you see adapting this to the Indian context, to the Indian scenario? Do you think there would be any special requirements to bring such a technology to India in terms of adaptability,
Right.
context, etc.?
Right. I mean, we have been doing it for the past almost 6 years now, essentially in India. So we haven't had any blowback as it comes to Indian context, really, because in many ways, basically, the same technology that's been adapted in all of the offices across the world, basically Europe, the US, Latin America, essentially, have been applicable here in the same manner. And we've not found, obviously, people are slightly unaware of what EEG is or what brain mapping is, and they like to be slightly more reticent about the entire thing. But then once you explain to them then how the procedure works and explain to them how the system actually works and what we're actually doing, they tend to be very comfortable with the entire process altogether. So we must have tested in India, I would say roughly about maybe 30 to 40,000 people so far. Out of that entire sample, I would say about maybe 10 or 15 people have had an issue with it, really. That's a minute sample of people who have an issue with the entire process altogether, because we try and make it as comfortable for the client and for the participants as well. And we make the process as simplistic and easy for them to basically go through.
Sure. Yeah, wonderful. I'm actually curious. I want to hop in with one question of mine right now. I read this really interesting study by Neurons Inc. about the whole ongoing political issue right now, and how Neurons Inc. is trying to help give their perspective. Do you want to speak a little bit about that? That would be very, very,
Sure.
I think it would be highly engaging. Yeah.
Sure. So, I mean, I'm not sure what's the case in the US, but at least we found that a lot of European countries applying neuromarketing to political issues seems to be an issue in that community, basically. So you can't technically apply any neuroscience techniques when it comes to Europe. I'm not entirely sure what the rules are in the US, but in Latin America, we tend to do work with a lot of political companies. We tend to work with a lot of political clients directly, who tend to utilize neuroscience service to understand voter responses altogether. Right now, what we did was essentially an in-house study wherein we tested how, for example, Biden's marketing campaign, his advertising altogether, works against Trump's advertising, for example. Obviously, there's a multitude of things that you can test. You can test their speeches, you can test their debates against each other, you can test how people perceive them as their personalities. But what we ideally wanted to understand was the print media, the videos that they're basically putting out there in the world. How well are they communicating their particular brand message with their voter base altogether? Because politicians in itself are brands in themselves, basically. So if we can help Coca-Cola figure out how to best communicate yourself to the client base, it's the same thing for politicians altogether.
Absolutely. I think it's a super fascinating, and neuropolitics is going to be the very new, exciting subject to kind of make a foray into. And with that, I have one last question for you, Shikhar, again. And that's really, I think, a point which comes up very often. I'm sure you've heard this before, which says that, you've been able to develop a targeting marketing platform to, understand consumer behavior. But isn't that such sort of, couldn't this potentially manipulate the target population? Couldn't these techniques be probably, and this is more of, I think, like ethics related questions. So how do you have that fine line, differentiating between personalizing strategies for users versus, making sure that they're not being, manipulated or nudged towards extreme spending and things like those. Yeah. And this is from Aditi. I could just add this on Zoom. Yeah.
Right. So I think one thing people tend to misconstrue neuromarketing as is basically they tend to feel that we're using brain techniques to essentially manipulate the consumer in some way or the other, which is very, very far from the truth, actually. We're not manipulating the end consumer. All we're essentially doing is using another set of tools to essentially understand consumer behavior that has been done for about 100 years or so. So using traditional methodologies has been a part of traditional market research for decades and decades and decades now. The only thing that we're doing is using more advanced tools to understand on a far more accurate and behavioral level at this point. But there's no reasonable way that we can basically manipulate consumers into doing something they're not willing to actually do. All they're actually doing is monitoring what they actually really do, what they like, what they do in their day-to-day life, and monitoring that and trying to figure out how we can make better ads for them, make better products for them, make better advertising campaigns for them altogether. So it's actually in their favor to make it less stressful for them, more engaging for them, more attention grabbing for them, rather than manipulate them. We're actually trying to make it more appealing for them in the first place.
Right. Right. And Max, do you want to add something about that from the education perspective? When you are monitoring children, how do you draw that fine line and make sure? I know there's been a lot of talk about this, so probably you can help clarify a little bit of that from your end.
Yeah, I think we are now the experts in understanding the nuances of the situation.
Sure.
And the way I think about it is this: we've been able to show the scientific backing for using this type of technology to improve certain education outcomes. So we're confident that it works. We also have invested a lot of time, a lot of resources into data privacy work. We have our own internal data privacy team. We meet every single week to make sure that we're considering all the different nuances of the situation. And we also work with a variety of outside partners in the data privacy space to make sure we're really thinking all of these things through. So even if the data privacy is lined up and the scientific support is lined up, it could still be true that certain applications of BCI or BMI, their time is not here yet. And what I mean by that is typically when people look at this technology, they might think, oh my God, this is going to read my mind. What is this? What's happening? And even though those things aren't true, there are other ways we can apply this technology that I think feel a bit more approachable. So that's why, we focus on helping athletes improve their performance, helping people reduce their stress, things that feel more approachable. And we'll continue to do our research with different academic partners and build up the scientific base. And I think eventually the world will get to a place where these types of interactions are more approachable. But there are certain things that really do matter to us. So for example, the environments that we've created right now with our technology, they're really personal to the user. So we keep the feedback in a closed loop with the user. And just as an example of things you can do to make the experience more appropriate. But I think the kind of guiding line here is you need to respect boundaries. You need to obviously respect privacy. And it's important for companies to operate within a model that works for the market, right? You can't force the market to change so much. So we kind of, we are respecting those boundaries and focusing on what we're good at and taking our time with, how we apply this technology.
That's fantastic to hear. I think that's a fantastic note. And I think that also brings us to the fact that, Neurotech X is such an important organization to help spread about education, about such kind of tools and technology, familiarize people, make it more commonplace, bring out the whole discussion about like ethics into into the fore, and make it a more normalized conversation where people don't fear, but they actually understand it and they are ready to make an advent into these fields. With that, I think I would love to thank all of us, all the speakers, all the participants, all the attendees for a fantastic session today. We really apologize for the minor technology glitch which we had. I think I could drive home the point that we have a social media handle. Everybody heard that on a loop. So please do participate in our social media challenge. Use the hashtags Namaste NTX India and NTX Goes Desi. We hope to see you all tomorrow. Please be there sharp 7:30 p.m. IST. PD, and we will be, of course, posting the same timings in the meetup links, which you would be receiving in the Zoom information. Other than that, please do register for NTX India, for the NTX social media handles. And I really want to thank you all for a wonderful session today. I hope to see you all tomorrow with the same energy, the same enthusiasm, and a lot more gusto, and hope to take it on in a full-on manner. Thank you so much, Dr. Naveen Gupta, Max, and also Shikhar. It was fantastic having you all here, and to our wonderful, wonderful audience. Thank you so much. And of course, my NTX team. Thank you so much. Well, with that, we end today's session. We hope to see you all tomorrow.
Yeah. Okay. Thank you, NTX team. Yeah.
Thank you so much. Thank you so much.
Thank you.
I've also dropped in NTX India's email ID. Please reach out if you have any queries, and we'd be happy to answer. Thank you so much, and see you tomorrow.
Yeah. All right. Thank you.
Yeah. Thank you.
Thank you, guys. Thank you, guys.